This video discusses one-to-one functions. A function f of x is one-to-one if for x1 and x2 in the domain of f, if x1 is not equal to x2, then f of x1 will not be equal to f of x2. Equivalently, if f of x1 is not equal to f of x2, then x1 will not be equal to x2. That is, no two inputs map to the same output. A real-life example of a one-to-one function is people and social security numbers. Each person is assigned exactly one social security number, and no two people can have the same social security number. This differs from a regular function because with a regular function, two different inputs can map to the same output. But with a one-to-one function, one input is paired with exactly one output, no repeats. We're going to take a look at ordered pairs, graphs, and equations and determine whether they are one-to-one. We'll start with ordered pairs. Recall, to determine whether a relation is a regular function, we look at the x values of the ordered pairs. If the x values repeat, then the relation is not a function. Well, that's still going to be true when determining whether a set of ordered pairs is a one-to-one function. There's just additional criteria. To determine whether a function is a one-to-one function, you're also going to look at the y values of the ordered pair. If the y values repeat, the function is not a one-to-one function. So neither the x values nor the y values can repeat in a set of ordered pairs to be a one-to-one function. So let's take a look at a couple sets of ordered pairs. We'll determine whether the sets are one-to-one functions and we'll justify. Our first set of ordered pairs, if you look through, we see that neither the x value nor the y value repeats. So this first set of ordered pairs is a one-to-one function. And our justification is that each x value is paired with a unique y value. Let's take a look at our next set of ordered pairs. Is this a one-to-one function? You'll notice that the y value of 6 repeats. The x value of 3 and the x value of 7 both pair with the y value of 6. This would be like saying that two different people had the same social security number, and that is not possible. So this is not a one-to-one function. And our justification is that two different x values are paired with the same y value. Now let's look at the rule for determining whether a graph is a one-to-one function. Recall that a graph must pass the vertical line test to be a function. So that's going to be true for one-to-one functions as well. There's just an additional criteria. A function is one-to-one if it also passes the horizontal line test. And the horizontal line test is very similar to the vertical line test. A function is one-to-one if no horizontal line intersects the graph in more than one point. So in order for a graph to be a one-to-one function, it must pass both the vertical line test and the horizontal line test. So let's take a look at a couple graphs. Our first graph Definitely passes the vertical line test. There's nowhere that we can draw a vertical line and the graph hit more than once. But the graph must also pass the horizontal line test. And we can see that this graph is going to fail the horizontal line test. If we draw a horizontal line, it hits the graph more than once. So this is not a one-to-one function. And our justification is that it fails the horizontal line test. Let's take a look at our next graph. We'll start by making sure that it passes the vertical line test. And we know that this is the rational function, f of x equals 1 over x. So even though it looks like our graph goes vertical, we know it doesn't. It's slowly approaching that vertical asymptote at x equals 0. So this graph does pass the vertical line test. Now we'll test the horizontal line test, see if we can draw a horizontal line anywhere and it hit more than once. Again, we know that this graph does not level out to be perfectly horizontal at y equals 0. It's approaching that horizontal asymptote. So this also passes the horizontal line test. Therefore, this is a one-to-one function. And our justification is that it passes the vertical line test and the horizontal line test. Lastly, we're going to look at equations and determine whether the picture of the equation is a one-to-one function. So given an equation, what you want to do is picture the graph and then use the vertical and horizontal line tests to determine whether or not the function is one-to-one. Let's start by looking at f of x equals x plus 2. We want to picture what this graph is. Well, this is a line with a y-intercept of 0, 2 and a slope of 1. So if we draw this graph in, we see that we have a diagonal line, and now we want to use the vertical and horizontal line test. This graph passes both the vertical and the horizontal line test, so this is a one-to-one function. Be sure to include your justification. Next, we want to look at the function g of x equals the absolute value of x minus 1. Again, we'll picture the graph. This is our absolute value function that's been shifted down 1 unit. We can see that this graph passes the vertical line test, however, it fails the horizontal line test. So this is not a one-to-one function. And our justification is that it fails the horizontal line test.